Hi, welcome to this Corbettmaths video on the video solutions to the nets practice questions. If you need any extra help on nets, if you go to corbettmaths.com/contents and scroll down to video 4, there's a video tutorial on nets. Alternatively, you can just scan this QR code and it'll bring you straight to that video. Okay, let's get started. So, question number 1. So let's have a look at question number 1. So question number 1, we've got to match some solid shapes and their nets. So let's have a look and see what shapes we've got. So A, we've got a cube. So the net of a cube is going to be this net here. So let's match those up. Because if we start off with the base, then you've got your 4 sides which would fold up, and then this side would be the top. It would fold over to be the top. Then we've got this shape here, which is a square base pyramid. So with a square base pyramid, it's got a square on the bottom, and then it's got 4 triangles that fold up to meet at the top. So that's going to be this net here, where you've got your square and your 4 triangles which fold upwards to make the pyramid. And finally, we've got the cylinder, and the net of the cylinder is this net at the top here, where you've got this rectangle which would fold round to be this curved face, and then you've got the circle on the top and the circle on the bottom. So A would match with the net in the middle, B would match with the net on the bottom, and C matches with the net on the top. Okay, let's have a look at question 1b. So question 1b says name shape C. So shape C, if you have a look at shape C, it's a cylinder. So cylinder. And part C says write down the number of faces on shape A. So if we have a look at shape A is a cube, and if you think of a dice, it's got 6 faces, so it's got 6 faces. And part D says write down the number of vertices of shape B. So if we have a look at shape B is a square base pyramid. It would have 1, 2, 3, 4 vertices at the bottom and 1 vertex at the top. So altogether there'd be 5 vertices. So a square base pyramid has 5 vertices. And that's it. That's question number 1. So we matched up the nets to the shapes. Shape C was a cylinder. Question 1c says write the number of faces a cube have, which is 6, and 1d says write down the number of vertices that a square base pyramid have, and that would be 5. Okay, question number 2. Question number 2 says the diagram shows the net of a solid. So here we've got a net, and as you can see, it would be a cuboid if you folded round the 1, 2, 3, 4 rectangles and then folded up the 2 squares. That would make a cuboid. And question 2a says write down the name of the solid. Well, it's a cuboid. Question 2b says the net has 1 line of symmetry. Draw the line of symmetry on the diagram. So if we have a look at this net, it's got 1 line of symmetry, and as you can see, it would have a vertical line of symmetry looking like this, going straight down the middle like so. So that would be its line of symmetry there, because it's identical on both sides. It could fold over on top of itself. Okay, and question C says write down how many faces the solid has. So what I've done is I've just done a quick sketch of a cuboid. So here's a cuboid, and we've been asked to find out how many faces it would have. Well, it's got 1 on the left hand side, 1 on the right, 1 on the back, 1 on the front, 1 on the top, and 1 on the bottom. Altogether there'd be 6 faces. So that cuboid would have 6 faces. Question 2d says write down how many vertices the solid has. So it's got 1, 2, 3, 4 vertices. So remember, the vertices are where the edges meet, so those corners. So 1, 2, 3, 4 on one side, 5, 6, 7, 8. So there'd be 8 vertices. So it would be 8. And finally, question 2e says write down how many edges the solid has. So let's count its edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there'll be 12 edges. And that's it. Okay, let's have a look at question number 3. So question number 3 says, shown below is the net of a 3D shape. Circle which 3D shape it is. So this is the net of a cone. You've got this sector. This sector would wrap around to make a cone, the curved surface of the cone, and then the circle would be the base of the cone. So it's a cone. So that's the 3D shape that this is the net of. It's the net of a cone. If you have this sector, it rolls around to make that curved surface of the cone, and then you've got this circle on the bottom. Okay, question number 4. Okay, question number 4. Question number 4, we've been given a net, and we've been asked the net of which 3D shape is shown above. So this is the net of a 3D shape, and if you consider this triangle here, that would be the base, and the 1, 2, 3 triangles would fold upwards to meet at a point at the top. So it's going to be a pyramid, and it's a triangular base pyramid, and there's 2 names for that. You could either call it a triangular base pyramid or a tetrahedron. So we've got a triangular based pyramid, or you could call it a tetrahedron. Tetrahedron. Okay, question number 5. So question number 5 says, part of the net of a cuboid is shown below. So here we've got the net of a cuboid. It has got 1, 2, 3, 4, 5 rectangles. So it's going to need one more. And we've been asked to complete the net of the cuboid. So if we consider this rectangle here to be the base of the cuboid, you've got then the front and the back. So the front face and the back face, that would be the bottom. That would be the left-hand side. That would be the top. So we need to do the right-hand side here. And that's going to be the same as the left-hand side. So it's going to be a rectangle, which then goes out to, and use a ruler and a pencil here, and it goes out and over to, and then you join it up like so, and then that would be the right hand face. So that would be the right hand face, that would be the left hand face, and that would be the top. So we've completed the net of the cuboid. Okay, question number 6. So question number 6 says, shown below is a triangular prism. Sketch the net of a triangular prism. So it would look something like this. Let's just get a ruler and a pencil. So we would have the base, which is a rectangle. You'd have the left-hand face and the right-hand face. They're going to be rectangles as well. And then you've got the front and the back, which are triangles. So let's start off with the base. So let's start off with that rectangle on the base. So it would look something like this. So now we're going to have 2 more rectangles, one on the left-hand side and one on the right-hand side for the 2 faces that fold up and meet at the top. So let's draw those. And I've done mine a little bit bigger than the base, just because that's the way I've chosen them to be. And then finally, we're going to have our triangles, 1 and 2, one on the top and one on the bottom, and they're going to be the front and the back. And that's it. So that's my sketch of a net of a triangular prism. Okay, question number 7. So question number 7 says, shown below is a cube with a side length of 2 centimeters. So it's a cube and it's a side length of 2 centimeters. And that means that all the sides are 2 centimeters. And we've been asked to draw the net of the cube on this centimeter square grid below. So we need to draw the net of a cube, and it's going to be one with side lengths of 2 centimeters. Okay, so let's start off with the net of the cube. So I'm going to start off by drawing my first square like so. So that's my first one, and then I'm going to draw the base. So that's going to be the base, the bottom of the cube. Then my face on the left-hand side. That's going to fold up to be the left-hand side. This will be my face on my right-hand side. This will be the face at the front of the cube whenever I fold it up. And finally, I need a lid, and I'm going to put the lid here. So that's going to be the top of the cube, like so. And as you can see, because it's a side length of 2 centimeters. Each of these squares are 2 centimeters by 2 centimeters, and then that would be the net of a cube, which has got a side length of 2 centimeters. Okay, let's have a look at our next question. Okay, question number 8. Question number 8 says, shown below is a cuboid, and it's a cuboid which has a length of 5 centimeters, and then we've got a width or depth of 2 centimeters and a height of 2 centimeters. And we've been asked to draw the net for this cuboid on this centimeter square grid. So we're going to have, for the base, it would be 5 centimeters wide and 2 centimeters high, like so. And then the front and the back would actually be the same because they're 2 centimeters high and 5 wide. The top would be the same, the back would be the same, the bottom would be the same. So it's going to have 4 identical rectangles, which are all 5 centimeters by 2 centimeters, and then it's going to have a 2 centimeter by 2 centimeter right hand side and a 2 centimeter by 2 centimeters on the left hand side. So let's draw that. Okay, so started by drawing a 5 centimeter by 2 centimeter rectangle. So that's going to be my back of my cuboid. Now I'm going to draw the base of the cuboid. So it's going to be 5 centimeters by 2 centimeters, like so. Then the front of my cuboid, so 5 centimeters by 2 centimeters. And finally, the top of my cuboid, which would be here, 5 centimeters by 2 centimeters, something like that. And then I need my left-hand side. Now that was a square. If we go back up and look, it's a square, which is 2 centimeters by 2 centimeters. So we just need a side here, which is 2 centimeters by 2 centimeters. Let's just do it there and there. And then that would be the net of our cuboid, which has got 4 rectangles, which are 5 centimeters by 2 centimeters, and then the right-hand side and the left-hand side, which are squares. Okay, let's have a look at our next question. So let's have a look at our next question. Question number 9. Question number 9a says, shade 2 more squares so that the shaded shape is the net of a cube. So we've got 4 squares that are shaded on this grid. Now we need to make a cube, so let's just say this is the base, so that's the base of the cube. Then we've got the left-hand side and the right-hand side. That would be the top. Let's just do the front and the back, so let's just do shade this one. So that would be the net of a cube. That could be the net of a cube where you've got then the bottom, the left, the right, the back, the front, and the top. Okay, let's have a look at question 9b. Question 9b says shade 6 more squares to create a different net of the cube. So this time let's start it a little bit differently. Let's start off by doing this one. Let's say that's the base of the cube. And then let's shade the left hand one and the right hand one. That will be the left hand face of the cube and the right hand face of the cube. Now that's the base. Let's then say that's the front. And let's just do this one. That will come be the top of the cube. and then this can be the back of the cube. So this T shape could be the net of a cube as well, where we've got the bottom, the left, the right, the front, the top, and the back. And that's it. So these are two different nets, where we've got this one, which has got 4 horizontally and one above and one below. And then we've got this T-shaped one. Okay, let's have a look at our next question. And there's lots of different nets of cubes, and that's actually quite interesting how actually trying to create all the different nets that you can do for a cube. Okay, question number 10. So talking about cubes, we have got a question where we've been given 1, 2, 3, 4 different nets, and we've been asked which one of them is not the net of a cube. So we know that A is, we've just talked about that one, so A is the net of a cube. So one of these ones, either B, C, or D, will not be the net of a cube. Okay, let's consider B. So let's say that this square here is the base of the cube. So this would be the back, that would be the front, so that one would fold up and that one would fold up, and then that could be the base. This one would then fold over to be the right hand side of the right hand face of the cube. This one, if it folded up, would be the front, then this one would be then the top, and then this one would fold to be the left hand side. So that would make the cube if you folded that one up. Okay, net C. Let's say this is the base of the cube, so this one, and then that would be the back, that would be the front, that would be the right hand side. If that's the front, then that would be the top. Now this one then would go on the back as well. So this one would not be the net of the cube because there'd be no left hand face there. So that's not the net of a cube. And let's just check and see if D would make the net of a cube. If this one's the base, that's the right, that's the left hand face, and that would be the back. That would be the front, and that would be the top. So yeah, that would make the net of it. That would make a cube if you folded it. So which of these nets is not the net of a cube? C. Okay, let's have a look at question number 11. So question number 11, Harley has drawn the net of a cube. So here we've got the net of a cube, according to Harley. Explain why it's not correct. Well, there's only 1, 2, 3, 4, 5 squares. You would need a 6th square to make the net of a cube. This would not have a lid. It would fold up. If that's the base, you would have the left-hand face, the right-hand face, the back, the front, but there would be no lid to it. So there's not enough squares. It needs one more square. So I've just written down Harley needs to draw 6 squares. He's only got 5. Okay, let's have a look at our next question. So question number 12. Question number 12 says, here are 4 diagrams. We've got A, B, C, and D. And the question says, 3 of these diagrams show the net for a square-based pyramid. As you can see, net C would be the typical net of a square-based pyramid, or the one that I would usually draw if I was asked to draw one. But 2 more of these will work and 1 of them won't. And we've been asked to write down the letter of the diagram which is not the net of a square-based pyramid. Okay, so C is the net of a square-based pyramid. We've got the base, and we've got the 1, 2, 3, 4 triangles that would fold upwards to meet at that top of that square-based pyramid. Okay, let's have a look at A. So if we had A, that would be the front and that would be the back. They would fold up to be the triangles at the front and the back. This one would fold to be a triangle on the left hand side, and this one, if you folded A up, would be a triangle on the right hand side. So A would make a square-based pyramid. Let's have a look at B. B, we would fold this triangle up to be the front and this to be the back. This would then fold over to be the right hand side, and I don't think this one would actually make it across to the left hand side, so I don't think B is the net of a square-based pyramid. Let's check and see D. So D, that would be the front, that would be the right, that would then be the back, and then that would be the left hand side. So D would make a square-based pyramid if you folded it, so B is not the net of a square-based pyramid. Okay, let's have a look at our next question. So question number 13. Question number 13 says, below is a cuboid with length 6 centimeters, width 4 centimeters, and height 1 centimeter. And we've been asked to complete an accurate net of the cuboid, and each square represents 1 centimeter squared. So in other words, this is 1 centimeter by 1 centimeter. So we need to draw this cuboid. So it's going to have a base of 6 centimeters by 4 centimeters. It would then have a rectangle on the front, which would be 6 by 1. It would then have the top again, which would be 6 by 4, and then a 6 by 1. And on the right hand side, it would have a 4 by 1, and on the left hand side, it would have a 4 by 1. So let's draw that. And the base has been drawn for us. So we've then got our back, which would be 6 by 1. So it would look something like that. We would have the front, which would be 6 by 1 as well. And then we would have the top, which would be 6 by 4. So it needs to be identical to the base, which has been done for us. So that's the base, the front, the back, and the top. Now let's do the left hand side and right hand side. So the left hand side would be 4 by 1, and the right hand side would be 4 by 1. So it looks something like that. Okay, and part B says, work out the total surface area of the cuboid. Well, Each of these are the faces of the cuboid. So, and because each square is 1 centimetre squared, if we count the number of squares, that's going to be the surface area. So this is 6 by 4, so there'll be 24 squares in here if you counted them. 6 by 1, so that'll be 6 squares, and again you can count them if you want. There's 4 here, and there's 4 here, and there's 6 here. And the base again would have 4 rows of 6, that would have 24. And if we add it up, 24 and 6, that's 30, 24 and 6, that's 30, so altogether that's 60, 64, 68. So that would be 68 centimetres squared. Okay, let's have a look at our next question. Question number 14. So question number 14 says, below are the nets of two solid shapes. So we've got net A and net B. It says, write down the shape that is made from net A. Well, this would be a cylinder. We've got the curved face with that rectangle, which we'll fold around to make that curved face. And then you've got the flat face on the top, the circle on the top, and the circle on the bottom. So that's a cylinder. And B's a cone. Okay, part C. Christopher wants to make the net of a solid shape and has drew this shape. So he also looks like he's trying to do the net of a cylinder as well, but he's put the two circles on the same side of the rectangle. So whenever you fold that rectangle around to be that curved face off the cylinder, it's going to have two circles on the top. You actually need one circle on the top and one on the bottom. So that wouldn't work. You would have a hole. There'd be no circle on the bottom of the cylinder. There'd be a hole at the bottom. So I've just written he needs a circle on the bottom of the rectangle and he only needs one circle on the top. And that's it. Okay, let's have a look at our next question. So question number 15. So question number 15 says, showing us a view of a dice. So we've got 3 on the top, 1 on this side, this face, and a 5 on this face. And we're told the number of dots on the opposite faces add to 7. And if you look at the dice, if you've got a 1 on this face, you'd have a 6 on the other side. If you've got a 5 here, you'd have a 2 there. If you had a 3 there, you'd have a 4 on the bottom, and so on. And we've been asked to fill in the missing faces. So we've got a 5 on the bottom and a 1 on the back. So if we've got a 1 on the back there, well, we're going to need a 6 then here. So 1, 2, 3, 4, 5, 6. So you need a 6 there because the 1 and the 6 would be opposite each other whenever you fold them up. We would then have a 5 on the base here. So if there's a 5 on the base, then there needs to be a 2 on the top. And this side here, this face, and this square would be the top. If you folded up the right hand side and the left hand side, this would be on top. So that 2 needs to go there. And then in terms of the 3 and the 4, they can go either way around here. You could have a 3 here, 1, 2, 3. I'm just going to write a 3 there, and a 4 here, 1, 2, 3, 4. Or you can have those the other way around, the 3 and the 4. But you need to put the 6 on the bottom here because whenever you fold them up, the 1 and the 6 would be opposite each other. The 5 and the 2 need to be opposite each other, and the 3 and the 4 can be either way around. Okay, and that's it. So question number 16 says, shown below is a triangular prism. So we've got a triangular prism and we have got this right angle triangle on the front, and with a prism it means that it's a right angle triangle going the whole way through the prism. So it means there'll be a right angle triangle at the back of the prism as well. And it's the right angle triangle, it's got a height of 3 centimeters, a width of 4 centimeters, and the diagonal length is 5 centimeters. And in terms of the prism, it's 5 centimeters deep. Okay, and we've been asked to complete the net of the triangular prism. So let's have a look and see what we've been given so far. So we've been given 4 by 5. So if we have a look at our shape, 4 by 5 would be the base of the triangular prism. So we've got the base, which is 4 centimeters by 5 centimeters. Now if we consider the triangular prism, it's going to have the base, which is a rectangle. It's going to have this right hand face, which is a rectangle, and we're going to have this left hand face, which is a rectangle. So it's going to be 3 rectangles, and then there's going to be a triangle at the front and a triangle at the back. So it's going to be 2 triangles. So it's going to be 3 rectangles and 2 triangles. So we've got this base, which is 4 by 5. So we also need a 5 by 5 rectangle, or a square, which is 5 by 5. So let's draw that. So let's have a look and see. So we've got 4 by 5. So we now need to do a 5 by 5. So let's draw that 5 by 5 rectangle or square. Sorry, 1, 2, 3, 4, 5. So I'm going to draw that face there. So if that's the base, then that's the face that would fold over to be then the right hand face of that triangular prism. And then so we've drawn this face, then we need the other face, which is the left hand face, which is a rectangle as well, and it's going to be 5 long and 3 high. So if we then put that on the other side of the base, it's going to be 5 long and 3 high. So it's going to look something like this. So you'd have the base, this would fold up to be the left hand face, and this would fold over to be the right hand face. Now we need our triangles. Now in terms of our triangles, if we have a look at our net again, well, let's draw the triangles attached to the base. So let's do the triangles here and here, and let's have and see how tall and wide they would be. So we folded this out. We know if we put this triangle down here, it would have a height of 3 centimeters, and then it would join up with the 5 centimeters. So it's going to have a height of 3 centimeters. So it's going to have a height here of 1, 2, 3 centimeters. So if you folded this side up and folded the triangle up, they would meet, and then it's going to have a height of 3 centimeters there. And if you join up, then that should be 5 centimeters, and that's it. So that would be the net of our triangular prism. Okay, and let's have a look at our next question. Okay, let's have a look at question number 17. So we've been told here's the net of a cube. So we've got a cube, and we're told to write 6 different numbers on the faces. So the numbers on the opposite faces of the cube have a product, which means they multiply to give 90, a product of 90. So we need to put numbers, and there's going to be 6 different numbers on this cube, so the opposite faces multiply together to give us 90. So let's start off with the front and the back. So with the front, let's just say that's 90, and that then means the back would be 1, because 90 times 1 is 90. They've got a product of 90. In terms of the left-hand face and the right-hand face, well, let's say 9 and 10. 9 times 10 is 90. And then in terms of the base and the top, well, let's call that 2 and 45, because 2 times 45 is 90. So there's 6 different numbers, and the product of the opposite faces, the numbers on the opposite faces, would be 90. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on nets. I really hope you found this video useful. If you do need any extra help on nets, you can scroll down to corbettmaths.com/content and go down to video number 4, and there's a video tutorial on nets, or alternatively you can scan that QR code. I really hope you found this video useful. If you have found it useful, please like the video, please subscribe to the YouTube channel, and thanks so much. Cheers, bye bye.